we're seeing multilingual AI pop up everywhere, right? Seamless translations, content generation in dozens of languages. I mean, it feels like the global conversation just got a whole lot easier. But have you ever stopped to wonder if these digital polyglots have a bit of a secret? Well, let's call it an English accent.
That's exactly the fascinating question we're diving into today. We're exploring some really cutting-edge research. It's not just looking at how well these multilingual AI models perform tasks in different languages, but how natural their output actually sounds. Our exploration draws on work from researchers at Apple, Inria Paris, École Polytechnique, and Sapienza University of Rome. They've been investigating whether these models truly speak like a native in, say, French or Chinese, or if their heavy training on English data leaves a subtle but, well, detectable mark.
So, your mission for this deep dive, and you're already locked in, so get ready, is to figure out if this multilingual magic is genuinely natural, or if there's an underlying English influence shaping how these AI speak. We'll be uncovering some really surprising findings and actually some actionable insights that this research has brought to light. Our main focus will be a detailed research paper that tackles this very issue of naturalness in multilingual LLMs.
Yeah, and to really set the stage, let's think about what naturalness actually means when we talk about language models. It's more than just getting the words and grammar correct. It's about capturing the authentic feel of the language, the way a native speaker would naturally express themselves. Imagine someone who learned a second language perfectly in a classroom, okay? They might ace all the tests, but there could still be that subtle accent, maybe a phrasing choice that a native speaker wouldn't quite make. That's the kind of nuance we're examining with these powerful language models.
Okay, so this English accent idea is intriguing. What does it actually look like in practice? What kind of tells are we talking about?
Well, the core issue, as the researchers highlight, is that even though these LLMs can operate in multiple languages, they often exhibit these English-centric biases when they generate text in those other languages. This can manifest in the specific words they choose, the vocabulary, and also in the way they structure their sentences, the grammar.
Right. That makes intuitive sense when you think about how much more English data these models are typically exposed to during training. The research paper had a pretty striking statistic about one of the Llama models, right?
Absolutely. Yeah, even advanced multilingual models like the Llama 3.1 series are heavily skewed towards English in their training data. The paper points out that only about 8% of their massive training data set is explicitly identified as being in languages other than English.
Just 8%. Wow. That really puts it in perspective. So how does that imbalance translate into these English-like quirks in other languages?
Well, think about it like this. If your foundational understanding of language is built primarily on English, when you try to express yourself in another language, you might subconsciously carry over familiar English patterns. Right. This can be in how you phrase things, the grammatical structures you tend to favor, or even just the general way you approach expressing an idea. The LLMs, having been so heavily trained on English, do something very similar.
And the researchers also brought up the point about translated texts being part of the training data. I can see how that could, muddy the waters even further.
Exactly. A lot of these multilingual LLMs are trained on texts that were originally in English and then translated. Now, both human and even the best machine translations can have subtle translationese artifacts, little stylistic quirks that make them sound slightly different from something written natively in that language. So if LLMs learn from a lot of this translated data, they could inadvertently pick up and even amplify these unnatural English influence patterns when they generate new non-English text.
So in a way, they might be learning to speak other languages through an English lens. It's kind of like learning to play a foreign musical instrument, but still having your technique subtly influenced by your primary instrument.
That's a really insightful analogy.
Yeah.
Yes. And the researchers emphasize a critical oversight in how we currently judge these models. We're very focused on whether they can perform tasks effectively, can they translate accurately, answer questions correctly, write coherent text, all that stuff. But we often don't pay close enough attention to how natural their language actually sounds to a native speaker. This lack of focus means we could be missing important issues related to linguistic authenticity and, frankly, fairness.
Okay, so if our usual evaluations aren't catching this English accent, how do we go about measuring it? That's where these new metrics the researchers developed come into play, right?
Precisely. This is a key contribution of their work. They created 2 new ways to automatically assess how natural a large body of text generated by an LLM sounds. The first one focuses on the vocabulary and is called lexical naturalness.
Lexical, meaning the words being used.
Exactly. The words. To measure this, they use a technique called Jensen-Shannon divergence, or JSD. Think of it as a sophisticated way to compare the flavor of the vocabulary used by the LLM with the flavor of the vocabulary found in texts written by native speakers. It looks at the distribution of words. A lower JSD score means the LLM's word choices are more in line with what a native speaker would typically use. More natural, basically.
Okay, so that tells us if the AI is using the right kind of words. But what about how those words are put together? That's where the grammatical accent might be most noticeable, I'd imagine.
That's where the second metric, syntactic naturalness, comes in. This one looks at the sentence structure. It uses something called universal dependencies, or UD grammar.
UD grammar. What's that, basically?
Yeah, so imagine UD as a way to break down any sentence into its fundamental parts and how those parts relate to each other, the subject, the verb, the object, modifiers, and so on. It creates a kind of structural blueprint of the sentence. Then they use some, well, pretty advanced math, specifically Weisfeiler-Lehmann graph kernels and maximum mean discrepancy, or MMD, to compare these structural blueprints across large collections of text. Generated by the LLM on one hand, written by humans on the other. This helps them quantify how similar the sentence structures are. Again, a lower score here indicates that the LLM syntax is closer to that of native speakers.
So these metrics aren't just looking at individual sentences one by one. They're looking at the overall patterns in word choice and sentence structure across a whole bunch of text. Is that right?
Exactly. The researchers really emphasize that these are corpus-level metrics. They analyze the patterns across a large collection of texts, which is crucial for detecting subtle, repeated instances of unnatural language. Things that a human might easily miss when looking at just a few examples here and there.
That makes sense. It's about identifying these underlying tendencies rather than just isolated grammatical errors or awkward phrases. And the researchers have a specific way they define naturalness at this large scale, don't they?
Yes, their definition of naturalness at the corpus level is essentially this. Could a large collection of texts generated by this language model have plausibly been produced by a group of native speakers?
Hmm.
These metrics are designed to help answer that very question objectively.
Okay. So, armed with these new tools, the researchers then set out to see how some of the major LLMs actually performed in different languages. What did they discover when they put these models to the test?
Right. They compiled a carefully chosen set of 3,722 Wikipedia articles that were originally written by native speakers in English, French, and Chinese. This is really important because they wanted to avoid any influence from translation, that translationese we talked about. They needed authentic native text.
And then they had the LLMs generate similar content for these articles in each of the three languages and used their new metrics to compare the AI-generated text to the original human-written versions. Is that how it worked?
Precisely. They benchmarked several leading models, different versions of Llama, Qwen, Mistral, Nemo, a good range. The overarching finding was pretty clear. Generally, the language produced by the LLMs was less natural than human-written text, and this difference, this gap in naturalness, was more pronounced in Chinese and French compared to English.
That fits with the idea of a more noticeable English accent in languages less closely related to English, typologically speaking.
Yeah.
What were the specific findings when they looked at the vocabulary, the lexical naturalness?
Well, when they analyzed the vocabulary using that JSD metric, they found that the English text generated by the LLMs was the closest to the vocabulary used in the original human English texts. No huge surprise there, maybe. But interestingly, the biggest gap in vocabulary naturalness was in Chinese. This suggests that the model struggled the most to choose words in a way that felt native in a language quite different from English.
That's quite telling. So the further the language is from English structurally, the more obvious the unnaturalness in word choice becomes. What about the sentence structure? Did the English accent show up in the grammar as well?
Yes, definitely. Across all the models in all three languages, there were significant differences in sentence structure compared to the human-written text. But the English accent and syntax was particularly evident in the Chinese text generated by Llama 3.1. Their analysis revealed something quite striking. The way Llama 3.1 constructed sentences in Chinese was actually more similar to the structure of human-written English than to the structure of native Chinese.
Wow, that's a really significant finding. Can you give us an example of what that might look like? What kind of structures are we talking about?
Yeah, so the researchers identified specific short sequences of word types, part of speech, tag engrams, technically. Things like an adjective followed by a conjunction followed by another adjective.
Like big and small.
Exactly. Common in English, right? But they found this pattern appeared frequently in Llama 3.1's Chinese output, much more often than you'd find in native Chinese writing. Similarly, they found patterns like pronoun followed by an auxiliary verb, followed by a main verb like it was done. This reflects the more frequent use of passive voice constructions with helping verbs in English compared to Chinese. They also noticed a greater reliance on prepositions and articles, determiners like the and a in Llama 3.1's Chinese, again, mirroring English grammar, whereas Chinese tends to express these relationships in other ways, often more implicitly.
So, even if the individual Chinese words were correct, the overall feel of the sentence, the underlying grammatical framework, was leaning towards English. That's a really clear illustration of this English accent at work. The paper also had some surprising results regarding the Quen models, didn't it, given their origins?
Yes, that was somewhat unexpected. The Quen models, which were developed in China and presumably have access to a significant amount of Chinese training data, they actually consistently performed worse in terms of naturalness across all three languages compared to the Llama models.
That is surprising. Any idea why that might be?
Well, the researchers suggest that Quen's reported reliance on synthetic data during its initial pre-training phase might be a contributing factor.
Synthetic data, meaning AI-generated data.
Right. This is in contrast to the Llama models, which reportedly avoided using synthetic data for pre-training. This finding kind of hints that while synthetic data might be helpful for certain tasks or scaling, it could potentially introduce or reinforce unnatural language patterns. On the other hand, Mistral showed quite strong performance in English and French naturalness, which could be related to maybe a higher proportion of authentic native data in those specific languages in its training mix.
It really underscores how the makeup of the training data, the kind of data, can have these subtle but significant effects on the final outputs feel. The researchers also explored how the way you prompt the models and the decoding temperature you use can affect naturalness, right? What did they find there?
They did. They found that prompting the models in the specific target language generally led to improvements in naturalness for Chinese. Made the Chinese sound better, basically. However, for French, the impact of the prompting language was less consistent, which they speculate might be due to the influence of instruction tuning data, or perhaps just the closer linguistic relationship between French and English, making it less sensitive. Regarding the decoding temperature, that setting that controls the randomness of the output, they observed something interesting. Higher temperatures could sometimes improve syntactic naturalness for models that were already relatively natural, but it could actually worsen it for models that were already producing less natural language. Kind of counterintuitive. Vocabulary naturalness, though, generally seemed to improve with higher temperatures across models. But importantly, the relative ranking of the different models in terms of naturalness tended to hold steady across different temperature settings.
Okay, so it's not a simple fix like just tweaking a setting and suddenly it sounds perfectly native. It seems like a more fundamental issue related to how the models learn and represent language. This brings us to the next logical question. How can we actually make these multilingual LLMs sound more natural? Can we fix the accent?
That's the hopeful part. The researchers explored a technique called direct preference optimization, or DPO. The core idea behind DPO is to fine-tune the model by essentially showing it pairs of examples, one piece of text that is considered more natural and one that's considered less natural. The model learns to prefer the more natural-sounding phrasing.
Okay, but how did they get those examples of unnatural language to train against? That seems like the tricky part since you don't usually have data sets labeled unnatural.
Right, that was clever. Since those data sets don't really exist, the researchers had to create them. For tasks like Chinese essay writing and question answering, they artificially created less natural responses. They did this by taking naturally written text and then manipulating it using techniques like paraphrasing and, interestingly, back translation through English.
Back translation, meaning translate from Chinese to English and then back to Chinese again.
Exactly. And they found that this back translation method was particularly effective at generating the kind of subtly unnatural, English-influenced examples that helped the preference learning process the most. It kind of baked in that English structure.
That makes sense. The round trip through English could easily introduce some of those English-influenced patterns we've been discussing.
Precisely. They also used a metric called BLEU score to help filter these preferred and rejected responses. They wanted to make sure that the less natural rejected responses still conveyed a similar meaning to the more natural preferred ones, but just differed in style and naturalness.
So they essentially created a training signal that said, this sounds more like a native speaker and this sounds less like one. Then they used DPO to fine-tune the LLMs. What were the results? Did it work?
The results were very promising, actually. They applied DPO using a method called low-rank adaptation, or LoRA, which is an efficient way to fine-tune large models. They did this for both Llama 3.1 and Quinn 2. And they observed consistent improvements in both the vocabulary naturalness and the syntactic naturalness of both models, specifically on the Chinese essay generation and question-answering tasks they tested.
That's a significant step forward. So by specifically training the models to favor more natural-sounding language, they were actually able to reduce this English accent. Did they have an example of how the output actually improved, like before and after?
Yes, they provided a really compelling example from Chinese essay generation. Before this naturalness alignment, the Llama model used a phrase that was basically a very literal word-for-word translation of an English idiom. While it was technically grammatically correct in Chinese, it sounded overly formal and used a passive construction that just isn't common in everyday natural Chinese speech or writing. After the alignment, the model replaced this awkward phrasing with a much more common and natural Chinese expression that conveyed the same idea fluently.
That really highlights the practical impact of this fine-tuning. It's not just about bumping up some metric score, it's about making the language feel genuinely authentic. And did improving the naturalness have any negative impact on the model's other capabilities? Like, did they get dumber at answering questions?
That's another crucial finding, and good news. The researchers evaluated the fine-tuned models on a general benchmark called CMMLU, which tests a wide range of knowledge and reasoning abilities in Chinese. They found that improving the naturalness didn't hurt the model's performance on these general tasks. In fact, in some cases, there were even slight improvements.
That's really the ideal outcome, isn't it? More natural language without sacrificing overall intelligence or usefulness. It's interesting, though, that they also pointed out that higher naturalness doesn't always mean better performance on these standard benchmarks.
Yes, that's a really important point to emphasize. For instance, they noted that Quinn 2 actually scored higher on the CMLU benchmark than Llama 3.1, but as we discussed, it exhibited lower naturalness according to their metrics. This suggests that naturalness is a critical dimension of language model quality that we really need to consider alongside traditional accuracy-focused metrics. They're complementary, not the same thing.
This research is clearly very valuable, but the paper does mention some limitations and areas for future work, right? They didn't solve everything yet.
Oh, absolutely. As with any research, there are limitations to consider. One big one is that the study primarily focused on English, French, and Chinese, relatively high-resource languages. They didn't include lower-resource languages, mainly due to the challenges of finding large amounts of native text data and the necessary linguistic analysis tools for those languages. Also, their benchmark was focused specifically on Wikipedia content, which is a particular style. And the naturalness improvement techniques were mainly tested on Chinese open-ended tasks, because that's where they had the data.
And the researchers also pointed out the difficulty of getting humans to consistently evaluate naturalness at a large scale, which really highlights the importance and value of their automated metrics, doesn't it?
Exactly. Getting consistent human judgments on the subtle aspects of naturalness across thousands of texts is a huge challenge. It's subjective and time-consuming. The automated metrics offer a more scalable and arguably objective way to tackle this problem at the corpus level. They also made it clear, importantly, that their study was focused strictly on linguistic naturalness and didn't delve into the equally important area of potential social biases in language models. That's a whole other can of worms.
Right. So there are still many avenues to explore. What are some of the future research directions they highlighted? Where does this go next?
Well, they suggested expanding this kind of evaluation and naturalness improvement to many more languages, especially lower resource ones, and also looking at different types of text beyond Wikipedia, like conversational AI, creative writing, etc. They also proposed exploring other methods for creating those preference datasets used for fine-tuning, maybe more efficient or effective ways than back translation. And, of course, further investigating the intricate relationship between naturalness and the other capabilities of these powerful language models. There's still lots to learn there.
Okay. This has been a truly insightful deep dive into this whole English accent phenomenon in multilingual LLMs. Let's try and quickly summarize the key takeaways for everyone listening.
Sure. So in essence, this research shows us pretty clearly that multilingual language models often do have a detectable English accent in their non-English output. It's real. And crucially, this can now be measured objectively using these new, sophisticated corpus-level metrics for lexical and syntactic naturalness. The good news is that this unnaturalness isn't necessarily permanent. It can be reduced through targeted fine-tuning techniques like direct preference optimization. And perhaps most importantly, this improvement in naturalness doesn't necessarily come at the expense of the model's overall task performance. You can make them sound better without making them dumber.
And this isn't just an academic curiosity, is it? As LLMs become more and more integrated into our multilingual world for communication, content creation, you name it, understanding and addressing these subtle biases is really crucial. It's about ensuring linguistic fairness and the authentic representation of different languages in the AI-generated content we're all increasingly interacting with.
Absolutely. Really makes you think about the nuances of language and the importance of sort of cultural authenticity in how these powerful models communicate across linguistic boundaries.
So here's a final thought to chew on as we wrap up. Now that you're aware of this potential English accent, what subtle traces of it might you start to notice in AI-generated content in different languages? Maybe in translations you use or chatbots you interact with? How might this impact your own interactions with multilingual AI or even the way you perceive the information it provides? It definitely gives you a new lens through which to view these technologies. And as the research hinted, there's still a lot to unpack regarding the impact of things like prompting and decoding settings, so this is definitely an ongoing area of discovery.